Hey, welcome to my video on graphing nonlinear inequalities. You should already know how to graph a linear inequality at this point. Now we're going to look at how to graph a nonlinear inequality on a two-dimensional coordinate grid. When I look at the question here and it says y is less than x squared minus 4x plus 3, and they're asking me to graph it, I recognize that it's nonlinear because of this x squared right there. That's how I know I'm going to get the shape of a parabola. And to help me, I can recall what we know about graphing a nonlinear function. Well, you could get out your graphing calculator, plug x squared minus 4x plus 3 into the y equals section, and then you could use your table and graph and go through that process. But what if you didn't have those tools? Well, I'm going to remind you that what we did was we chose the values of x. We just created for ourselves a little xy table, and we picked values of x like -3 to 3. And then we plugged each of those values in to the equation to find the corresponding y value. So I'd take -3 and I'd plug it in, giving me y equals, make sure you put the -3 in parentheses, squared, all right, minus 4 times -3 plus 3. And when you do that, you find out that y equals 24. All right, and we can continue filling out all those pieces, 24, 15, 8, 3, 0, -1, 0. And we notice that we're not quite all the way back around, so I'd continue my table here going 4 would have to be 3 because it's symmetrical, and then 5 would be 8. And I'm not going to continue because 15 and 24 were off my graph. And from there, we just go ahead and we plot our points. All right, so I take this here, I plot the ones that fit. I'm not going to do -3 or -2. They're too high. My graph only goes up to 12. So -1, 8, I could plot that point. 0, 3. 1, 0, 2, -1, and then back up again. It's symmetrical, so I'm just going to mirror that. And then we'd go ahead and we'd try to sketch our parabola here. All right, and we just kind of come down and connect our points knowing that it is a curve. All right, we're going to give it a nice round bottom there. All right, and then back up again. And that's how we'd graph a nonlinear function that would give us the shape of a parabola. Well, you need to be able to know how to do that because when we go into an inequality, the base aspect of this starts the exact same way. We're going to start with those same points, but then we're going to decide how do we want to actually plot our line, and we look to our inequality symbol to tell us, are we going to do an open curve or a closed curve here? In other words, are we going to do a solid or a dashed parabola? And in this case here, I see that it's just less than, and that tells me that I'm going to do a dashed parabola, otherwise known as an open parabola for my reference curve here. All right, let's go ahead and do that. All right, and then we see it looks like this. We got a nice little sketch there. And then we're going to do our shading just like we did before. All right, when we're going to identify our shading, we're going to find out, am I going above my parabola or below? That can be a challenge to identify above and below. So I encourage you to either test a point on either side. A great way to test it right here, testing the point 0, 0. I can plug in 0 is less than 0 squared minus 4 times 0 plus 3. And if 0 works, then we're going to shade in the area where 0 is. And we see 0 is less than 3, which is true. That means I'm going to be shading where 0 is. Well, 0, 0 is right here, so I'm going to be shading on the outside of the parabola, as it would seem. Another way to look at it would be to look at our y-axis. And if I put my point here on my y-intercept, and it says it's less than here, I'm not underlining that, I'm just pointing it out, but y is less than, where is it less than? Well, it's less than below that point. And I could do that with any point. Here's the point here, just like the line, it's less than below. I'm going straight down from each of these points. All right, and that would put shading below my parabola, or what looks to be on the outside of my parabola. So I would use this as my boundary right here, my boundary parabola instead, and I would shade everything out here. And I'm not going to take time to actually shade this whole screen here, all right, but it would be everything outside of my parabola here would be my solution region. Any point out there would work. All right, now if you wanted to plug this into your graphing calculator, let me remind you of our symbols. All right, as we come back to our symbols here, these symbols over here remind you of how you can put it into the graphing calculator. And so you can actually plug in this inequality into the graphing calculator and you could see where to shade, and that'll be very, very helpful. A reminder that it will not show you dotted lines. All right, so whether it's less than or greater than, you just have to use the same symbol, and it's just going to show you shading in the correct region for our solution region. So if you have a graphing calculator, I'd like you to go ahead and plug this one in. Notice our change at this point. I have now changed it to a greater than symbol. I want you to see where the shading's going to be. Well, if you've done that, now you come back and we're going to check to see if you're right. And if you can't do that with a graphing calculator, you can test a point. All right, again, you can always test 0, 0. If I plug 0 in this time, I'm going to see that 0 is greater than 3. But that is not true. So I'm not going to be shading where 0 is. I'm going to be shading in the other region, which in this case would be inside our parabola. If you're reading our symbol, we now see that y is greater than x squared minus 4x plus 3. Well, x squared minus 4x plus 3 represents our parabola. So greater than, if you pick any point and you go greater than, it'd be above, all right, that parabola, or moving up from there. And you can see I'm going to be shading everywhere inside of my parabola. And so I'm going to go ahead and do that now. And again, I'm using this as my boundary curve here. All right, and I'm just going to be shading everything inside of my parabola. That would be my solution region. So points inside my parabola would make this inequality true. Points outside of my parabola would not make the inequality true. All right, so let's take a look at this other nonlinear function here that you could be graphing, and that is an absolute value function. Absolute value functions have some similarities to parabolas, and we can graph them the exact same way. I mean, you can plug them into your graphing calculator. I'll tell you how to do that in a moment. But you can still just treat it as if it were an equation. So in this case, y equals the absolute value of x plus 3. And you can pick your own values of x. And so I can set up a table here, and I can pick any values of x that I want. Now, there's a reason I'm picking these values, but again, you can pick any values you want. And we can take each of those values and we can plug in our value for x into our equation at this point. And I'll tell you right now, the absolute value makes everything positive when you get down to one number. That's just a reminder of how absolute value works. So if I plug in -5, I'm going to simplify this by going -5 plus 3 is -2. And the absolute value of -2 is 2. So that means that 5 is going to give me 2 in my table. And you can keep plugging in values to fill out the rest of that table. And if you do so, you'll get 1, 0, and then it will go back up again, 1, 2, 3. And then we can just start plotting those points to see what it actually looks like here. So -5, 2, -4, 1, 3, -3, 0, and so on. All right, we start to recognize a pattern, and that pattern is actually going to continue in both directions, where it's actually going to give me a nice V. It's a line coming in until it hits the x-axis there and then bounces back up. This is what the graph is going to look like when it's all said and done. And now we go about looking at our inequality. And notice the type of line that I drew here. All right, the type of line that I drew was a solid line, or a solid V, because it is equal to here, and that's my boundary point. And then now let's talk about our shading. It is greater than. Well, where is our graph greater than this absolute value graph? All right, where is it greater? What's the solution region that is above? Well, if I pick any point like this one here and I go above, all right, above is going to be in this region up here. All right, and I can see that that is going to be my solution region, and I can go ahead and I can shade that whole section in up here. This whole section up top is going to be my solution region where y is greater than the absolute value of x plus 3, because these represent all the y values that will be greater than my graph here of this V. And to verify this, you can always test a point. Pick any point that you want and plug it in. The easiest point to pick is always 0, 0. And if I pick 0, 0 and I plug it in, I'd say 0 is greater than or equal to the absolute value of 0 plus 3. And if I simplify that, I find that 0 is greater than or equal to the absolute value of 3. And the absolute value of 3 is 3. Well, 0 greater than or equal to 3? No, it is not. And that's why 0, 0 is not in my solution region. All right, but what if we change that? What if now we did our y is less than or equal to the absolute value of x plus 3? Well, now all of a sudden, if I look at every single point and identify less than, that's points now below my parabola, not my parabola, my absolute value graph. All right, and so my shading region is going to be everywhere down here. And again, I'm not going to do this whole thing because that'd be crazy. All right, but my border is going to be right along here and then up. And what about points on? Well, on, it's a solid line here, so we're a solid graph here, and so it will be solutions to this inequality because it's allowed to be equal to or anything less than. Now, I bet you're wondering, how do I plug this into my graphing calculator? Well, in your graphing calculator, you can go to the y equals section. All right, and you'll see y1 equals. And then we want to put the absolute value. Well, where is absolute value located? Well, you have a button just beneath the second button that says math. And you can see that button right here. All right, and if you type math, you're going to see some options that come up. There's a whole bunch of different options. You may have used some before, but it's going to have math right here. And then the next option over is going to say num, and that's the one I want you to go to, and you have to press the right arrow to go over to that. And I help you remember that by saying when math makes you num, comma, you get abs. And that's my workout advice for you. All right, because when you go over to num there, you're going to see the very first option then is abs with a parenthesis. And that is what we want to choose for absolute value. And you can just press enter there on number 1 in order to select abs for absolute value. And that's going to generate something that's going to look like this. Abs, parentheses. And then from there, you can put what's inside my parentheses, which in this case is x plus 3, and you can end your parentheses. Then if you go to graph it, you'll get the graph of the absolute value function. But if you want it to be an inequality, particularly this one right here, y is less than or equal to, make sure you come over to this line and hit enter until you get to the symbol that looks like this, which is less than. And that's how you'd graph this one. You actually see the shading that works out. I want you to try and do that if you have your graphing calculators on this next one. All right, try and graph this one in your graphing calculator, see what you get. All right, well, you should have gone and plugged it in, and I'll put it up here. It would have been y1 equals, and if you went to math and then over to num and selected abs, sorry, you would not have done that first. You want to do a negative first, and then you would have done that, and you would have gotten abs, parentheses, x. Make sure you end the parentheses and then hit plus 2, and then you're coming over to this side, and this time it is a greater than, so we are going to be going above, and you want to toggle your symbol so it looks like this little triangle here. And that's what it should get you. And then you can see if it actually worked out for you. You can go to the table and get your points to plot it. And if you did it correctly, this is going to be your boundary graph here. We got a solid line. You've got your points. Notice this one is facing down, and that's all due to this little negative right there, which flipped things upside down. And then you got to decide what side you're shading on. Well, if you're looking at your graphing calculator, you already see that. But in this case here, if it is greater than, that means it's going to be above. Pick any point, and we're going above or up. All right, and so we're going up every single time. No matter what point you pick, we are going up, and that's going to be our shaded solution region. It's going to border right along here. All right, so that's going to be our border. All right, and then our shading is anything above that. And to verify, you can always test a point. I always recommend testing a point. The best point to pick is 0, 0. And if I plug 0, 0 in here, I find that 0 is greater than or equal to negative absolute value of 0 plus 2. Well, that's going to give me 0 is greater than or equal to 2. Well, in this case, that is false. That is not true, so 0, 0 should not be located in our shaded solution region. What if I switch it? All right, now where's the shaded region going to be? Well, if you guessed right, you are going down now. It is less than, so it's everything lower than my absolute value. And so that's going to be my shaded region now, and I could use this as my border. All right, go down the border there, and then shading everything inside here. And just to verify, you can always test a point. Once again, I'm going to pick that point 0, 0 right in the center there. Now this time 0 is less than or equal to negative the absolute value of 0 plus 2, which gives me 0 is less than or equal to 2. And that is true. That's why 0 is located right here inside my solution region. At this point, I hope you're comfortable graphing nonlinear inequalities. If you have any other questions, come see me.